Okay, so let's take a look at the exercises of chapter 2. I did exercise 2.1 that reads define a better version of make ret that handles both positive and negative arguments. Make ret should normalize the sign so that if the rational number is positive, both the numerator and denominator are positive. And if the rational number is negative, only the numerator is negative. And here I reported the previous version of make ret that makes use of GCD, greatest common denominator, to reduce the rational number, so that if you plug in 2 and 4 in this constructor, your rational number is 1/2. And then here we have also defined numer and denom, that are the two selectors to access the first and the second element of the pair that we have that we can construct using make ret. We have also this helper procedure print ret to display the rational number, and here we have a very simple example when we define 1/2 by using the constructor make ret and plug in the arguments 2 and 4. And we can change a bit this simple definition and add a condition after having defined. So first we compute the GCD. Then we divide both the numerator and the denominator by G, and we obtain N1 and D1. After that, it is a simple condition is enough, meaning that if the denominator is negative, if the denominator is smaller than 0, then we construct the rational number, we construct the pair by inverting the sign of both the numerator and the denominator. Otherwise, we construct the pair in the traditional way. So this is the exercise, and here I did a bunch of examples, a bunch of tests to ensure that everything is correct, and we can see that. Okay, I'm in the directory, so racket x21. And so we can see that we define 1/2 as using 2 and 4, and we are given 1/2. Then we construct minus 1/2 by giving 1 and minus 2, and we obtain minus 1 divided by 2. And the same when the minus is in front of 1 instead of in front of the 2, and we obtain minus 1 divided by 2, and also finally the positive 1/2 when both the numerator and the denominator are negative, and we obtain 1/2 positive. And this is it for the exercise 2.1. Let's take a look at exercise 2.2, another very simple exercise that reads, consider the problem of representing line segments in a plane. Each segment is represented as a pair of points, a starting point and an ending point. Define a constructor make segment and selectors start segment and end segment that define the representation of segments in terms of points. Furthermore, a point can be represented as a pair of numbers, the x-coordinate and the y-coordinate. Accordingly, specify constructor make point and selectors x point and y point that define this representation. Finally, using your selectors and constructors, define a procedure midpoint segment that takes a line segment as argument and returns its midpoint. The point whose coordinates are the average of the coordinates of the endpoints. So, very simple. We can define a make segment constructor that takes two arguments a and b and construct a pair. Then we can define the two selectors accessing the first element and the second element of the pair using car and cooler, and we can do basically the same to create a make point constructor and x point and y point selectors to access the first and the second element of the point. Then we are left with the construction of the midpoint segment procedures that take as argument a segment, so a pair, and we first define through the selectors for the point and for the segment the x1, x2, y1 and y2 coordinates, and then we can use the make point procedure to create to construct a pair representing a point which is exactly the midpoint by simply taking the average of the x coordinates and the y coordinates. And again, here we can show how this code works. And we can see that, for example, by constructing the segment that on the plane has coordinate as start the point 1, 2 and has end point 1, 4, the midpoint is precisely 1 and 3. So in this case, it's 1 plus 1 divided by 2, it's 1, and 2 plus 4 divided by 2, that is 3. And also this exercise is done. Let's pass to the exercise 2.3 that reads, implement a representation for rectangles in a plane. Hint, you may want to make use of exercise 2.2. For the creation of points. In terms of your constructors and selectors, create procedures that compute the perimeter and the area of a given rectangle. Now implement a different representation for rectangles. Can you design your system with suitable abstraction barriers so that the same perimeter and area procedures will work using either representation? So here I think I came up with the correct solution to this exercise because at first I've defined this constructor make point to create a pair representing a point in the plane. then the two usual selectors to access the first and the second element of the pair, so the x coordinate and the y coordinate of the point. And then I decided to represent a rectangle by using a pair, and that pair is a pair of two pairs. The first pair is a point, is the bottom left point of the vertex of the rectangle, and the other pair contains the sides of the rectangle, and in particular the base and the height of the rectangle. In this way, the computation of both the perimeter and the area is very straightforward, and however, the rectangle is perfectly defined because once you have the bottom left corner, or for what matters, any vertex of the rectangles, if you also have the length of the base and the length of the height, by adding or subtracting those lengths to the coordinates of the vertex, you can obtain all the other three vertices. So with this approach, I defined a make sides constructor for base and height, the two selectors to access the base and the height, and finally a constructor for the rectangle, make rectangle, by taking as argument bottom left point and sides. And bottom left point, as I told you before, it's a pair representing the bottom left vertex of the rectangle, whereas sides is still a pair containing the information about the base and the height. Of course, I can define the two selectors to access the bottom left corner of the rectangle, and also the sides, and also the base and the height of the rectangle. And at that point, it's very easy to compute to define the procedure to compute the area using as argument the rectangle pair, and the same I did for the perimeter. So at this point, I define the corner as a point with x coordinate equal to 1 and y coordinate equal to 1. Then I defined a base of 2 and a height of 3. And finally, I construct the rectangle using those pairs. And as you can see, from the output, for here the important part, I mean, area and perimeter are defined by the base and the height, and as you can see, the area is 2 times 3, 6, and the perimeter is 2 plus 3 plus 2 plus 3 equal to 10. And that's it. That's it for all the exercises. These were very simple exercises, but useful to reason about and get used to these const, add, and encoder, and also to the prefix notation, because it's not easy to get used to such a syntax. So see you in the next video. Ciao ciao.